All right, hello everyone. Today we are looking at our lesson on solving multi-step equations. To start us off, we've got our two review questions. Make sure you go ahead, pause the video, and try these now, just because they're going to help you prepare for today's lesson. All right, so this first one is reviewing solving a two-step equation. When we talked about solving two-step equations, we said you always want to look at the side with the variable, so that would be this side over here, and start off by getting rid of your constant, which is that number by itself. In this case, that's the 4. So we would start by subtracting 4 on both sides. When we do that, those 4's cancel out because 4 minus 4 is 0. And then it would leave us with the negative 2p on the left side, and then 14 minus 4, which is 10, on the right side. Our last step would be, in order to get p by itself, I need to look at what type of math is happening here, because we have a number next to a variable that is multiplication, so the opposite would be division. I would want to divide both sides by negative 2. And when we do that, we are left with p all by itself. And then on the right side, 10 divided by negative 2 is negative 5. For the second one, it's asking you to simplify. The ways we know to simplify things are by distributing or multiplying and combining like terms. For a problem like this, we learned you always want to start with that distributing part. You want to start right here by multiplying out that 2 before you combine anything. So I know it's tempting. You see that 7 plus 2, you might want to go ahead and say that's 9, but we've got to multiply first before we combine anything. So starting off, if I distribute my 2, it would give me 2 times 2b, which is 4b, and then 2 times that minus 5, which is minus 10. Now I'm looking at this. If I'm looking for things to combine, one of the first things I see is that 7 minus 10. 7 minus 10 would give me that negative 3. And all I did was I just copied down my 4b and my minus 3b. After that, I see a 4b minus 3b. I can combine those two because they both have b's. So 4b minus 3b is 1b. But we've learned instead of writing 1b, you can just write b because I see the 1b there. So negative 3 plus b. There is nothing else I can combine. Negative 3 is a number, b is a variable. We can't combine things if they aren't like terms. So there, they both don't have b, so I can't combine them. So that would be my final answer. You might have also written b minus 3, both of those say the same thing. In both problems, b is positive and that 3 is negative. So the order those terms are doesn't really matter. Both of these are excellent warm-up problems for today because what we're going to be doing today is kind of like a combination of these two problems. Specifically, we are going to start looking at how you solve multi-step equations. At this point, you've learned how to solve one and two-step equations. We're going to get into multi-step equations. So you may be asking, what is a multi-step equation? A multi-step equation is just like an umbrella term for what we call any equation that requires more than 2 steps. The students who were in class with me last week correctly predicted that we were just going to be adding more and more steps on. So we learned 1 step, then we learned 2 step. So they guessed like we're going to learn 3 step and 4 step and keep going. We stopped counting the steps afterwards. We just called them multi-step because depending on the student or the person, it might take you 3 steps to solve and it might take someone else 4 steps. But what all these problems are going to have in common is they're going to be using what we learned about simplifying expressions to help us solve. So to begin, our first example looks like this. I notice that on my left side of my equation, I've got 8b plus 6 plus 3b minus 2. And then on the right side, I've got 37. I think before we get into solving, this is a great example of an equation where it's hard to look at and just know what number b would be. Even with the two-step equations last week, there's always some students who are looking at it instead of using all these steps we've been learning to solve. They're just looking at the equation and trying to figure out what number goes right there for the variable. But as these equations get more and more complex, it's harder and harder to look at them and just know what number b is going to be, especially since b is in two different places. But because it's the same letter, it has to be the same number. So it's hard to look at this and know, like, okay, what number would I have to put here and also here to make this whole side equal 37? That's still what we're trying to find. We're still trying to find what that missing number is, but it's harder just to look at. So instead, what we're going to be doing is using all this algebra we've been learning, right? We've been learning how to simplify things. We've been learning steps to solve these equations. What do you think we would want to do first for this? Well, when I look at this equation, this left side here is just dying to be simplified. Look at all these things over here. One of the first things you might notice is I've got an 8b here and a plus 3b here. They're both on the same side of our equation. We could just go ahead and combine those. We could say 8b plus 3b gives me 11b. And then notice I just copied everything else down. So I copied down my plus 6, I copied down my minus 2, and it still says equals equals 37. Looking at this left side here, you might have already done it. There's more things we can combine. We've got that plus 6 and that minus 2. I can go ahead and combine those as well. And voila, we get a plus 4 out of it. So I brought down my 11b, and then that positive 6 minus, minus 2 gives me that plus 4, and then it still equals 37. Just by doing that, just by simplifying this left side and getting 11b plus 4, now we're left with a two-step equation. So the remainder of this problem is just a review of what we did last week with solving one and two-step equations. We learned last week that when you have a two-step equation like this, you're always starting by removing that constant. Here it's plus 4, so if I do the opposite of plus 4, that is minus 4. So when I do that, that 4 minus 4 is going to cancel out for me because 4 minus 4 is 0. So that would leave an 11b equals 33. Now my next step, if I want to get b all by itself, right here, 11b means 11 times b. That's multiplication. So if I want to do the opposite, what should I be doing? I want to divide by 11. It's hard to show division when you're typing stuff, so I'll go ahead and add that. I'm going to divide by 11. When I do that, 11 divided by 11 is 1. If you're saying 0, make sure you look carefully. 11 divided by 11, 11 goes into 11 one time, so we get 1b, or just b. And then on our right side, 33 divided by 11 gives us 3. So we're left with b equals 3. Now, when I say b equals 3, what does that mean? We'll go back to that original problem. Our original equation looked like this. When we say b equals 3, when I'm solving this equation, I'm trying to find what that missing number is right here. I found it. That missing number is 3. So when I say b equals 3, I'm saying if I were to put 3 here and put 3 here, this entire side of the equation would equal 37. There's only one number b can be to make this side equal 37, and we think we found it. We think it's 3. So how do we check? Well, we check by doing exactly what I just said. If we think b is 3, I can check by putting 3 there for b and making sure this side here equals 37. The math word we learned for that is substitution. I can substitute 3 for b to make sure this side here equals 37. So when I go to check, I'm starting off with my original equation. Make sure you don't start off with one of these other equations. You always want to start off with the original one, because part of what we're checking for, so we're checking to see if that number is 3, but we're also checking to make sure we didn't make a mistake in solving. And if you use one of these later ones, it might not catch a mistake you made. So I'm starting with that initial equation, and then I'm going to substitute 3 for b. So notice anywhere I saw a b, I changed it to a 3. So here and here. Also notice that when I wrote that, I didn't write 83. I wrote it as multiplication. We've been saying that when you've got a number next to your variable, that means multiplication. So when you substitute, it needs to show that. So it says 8 times 3 plus 6 plus 3 times 3 minus 2. I'm still checking to see, does that equal 37? I don't know. Looking at this side here, we've just got a bunch of math we've got to do. We're going to start off with multiplication. We're going to start off by multiplying these two. When I do that, it leaves me with 8 times 3, which is 24, and 3 times 3, which is 9. Notice I just copied everything else down. Now we've just got all this math here. I'm just going to work from left to right. This goes back to order of operations, PEMDAS. When we learned that, we always want to go start from our left side and work right. So when we do that, 24 plus 6 gives me 30. 30 plus 9 gives me 39. And then I've got 39 minus 2 equals 37. Is that true? Yes. Why, yes, it is. So you might just leave it like that and say, okay, we're good to go. Some people like to just finalize it by showing 39 minus 2 is 37, and 37 is in fact equal to 37. It's up to you how you do it. But this right here should make you feel oh so happy inside because it's a sign you've solved it correctly and you found what that number needs to be to give you 37. So this was my example here. Oops. We don't want that. What we do want is our second example. Go ahead, pause the video here and see if you can figure out what we're going to have to do for this equation. Well, just similar to that last one, we want to start off by simplifying. Here, notice our variables on the right side, and notice what's going on over here. This right here is a problem we can simplify by distributing. So to start off, I would want to distribute or multiply my negative 3 to everything that's in parentheses. The negative 3 times the 2b is going to give me negative 6b, and what you want to be careful with is that negative 3 times negative 5. Negative 3 times negative 5 would give us a positive 15. I'm left with this. This is my two-step equation. When we go to solve, I'm going to find my variable. I'm looking at the numbers on the same side as our variable. These are the two numbers I need to get rid of. Where am I going to start? Well, with that plus 15, because it's our constant. It's the number by itself without the variable. To get rid of a plus 15, I need to do the opposite, and the opposite of plus 15 is minus 15. When I do that, the reason I'm choosing minus 15 is because 15 minus 15, that gives me 0. That cancels out. That's what I want to happen. So those would cancel. On my right side, I've got 27 minus 15. 27 minus 15 gives me 12. And then I can bring down that minus 6b or the negative 6b. My last step, if I'm trying to get b by itself, this right here is multiplication. I want to do the opposite of multiplication, which is division. I need to divide by negative 6. The reason we're dividing by negative 6 and not just 6, it goes back to what you get when you divide. Negative 6 divided by negative 6 gives me 1. I want 1b because 1b is just the same thing as b. And then over here on the left side, 12 divided by negative 6 gives me negative 2. Again, we've got our answer. Especially if you are doing this at home, you could always go back and check. Do you remember how you check? Well, you take the number you found for b and you substitute. You replace that number right here. So when we do that, it'll look something like this. Now notice I changed the way our equation looked just a little bit. I changed it to use these brackets instead. And the reason I did that is because it can get a little confusing when you're using parentheses to show multiplication. Another way you could do it is you could always just show that multiplication using a different way. So we've learned parentheses mean multiplication, but we also learned that little x means multiplication, the dot means multiplication. So it's up to you how you want to do this. Switching switching to brackets is one option, but you could have also kept it exactly like this and just said 2 and then used like the multiplication dot 2 times -2. Either way, it's going to look something like this. When we go to do the math, I always want to start here within our parentheses. Again, it kind of goes back to order of operations. That's why we wanted to learn that before we got into solving. But we want to start inside our parentheses. So when I do that, 2 times the -2 gives me -4. And then everything else is just copying down. When it comes to checking this math, I'm going to go inside my parentheses and say -4 minus 5 gives me -9. Remember, when they're both negative, you are adding and keeping that negative sign. And then our last step, -3 times -9, does it give us 27? Well, yes, it does. Alternatively, when you got to this line here, I said I'm going to keep going inside my parentheses and do -4 times -5 gives me -9. If you were instead thinking of distributing and using distribution to help you check, that is also an option. So you could have said -3 times -4 gives you 12, -3 times -5 gives you positive 15, and then finished by saying, why, yes, 12 plus 15 does give us 27. So it's up to you how you want to check and do that math. I think especially with this problem and the negatives involved in this problem, it's a good just reminder that if you are struggling with doing math with negative numbers, or like maybe not even struggling, but just like making silly mistakes here and there with negatives, that is one of the things that students need the most practice with. We spent a lot of time practicing it last quarter, but it's something that you could always use more practice on. So if you're feeling like you're making mistakes with negatives and you feel like you need extra help, more examples, just more practice to work on, please reach out to me or Denise, and we will do our best to help you, or just to pass along some practice if you need that. These were the 2 examples I wanted to look at. Let me erase my division lines again. I have got 2 for you to try. The first one looks like this. All right, so when you're solving this equation here, there are things to combine on both sides of that equation. So notice here on the left side, the -2 plus 44, that's the same thing as 44 minus 2, which would give you 42. And then on the right side, the 9a plus the 4a gives you the 13a. And then we still got that plus 3. We can't add in that plus 3 because this has a variable and this one doesn't. Once you've done that, it might have taken you like 1 or 2 lines, depending on if you did them in the same step or if you did one side first and then combined the other. But either way, you're going to end up with this. Our next step is to get rid of that plus 3 by subtracting 3 on both sides. We're subtracting because that's the opposite of addition. When we do that, that leaves us with 39 equals 13a. Our last step, this is multiplication, so I want to come in and divide by 13. When I do that, 39 divided by 13 gives me 3. And then over here, 13 divided by 13 gives me 1a, which is just the same thing as a. So we get 3 equals a. Hopefully you checked your answer. I'm just going to move us right along to the other one, which looks like this. Go ahead and pause the video, try this one now. All right, to start this problem here, we would want to simplify by distributing or multiplying that -2 with everything in the parentheses. When we do that, it leaves us with -8 plus 6m equals -14. Make sure you've got a plus sign there. Where's that plus sign coming from? It's a negative times a negative, which gives us positive. After that, we want to start with our constant, which is -8. It's tempting to say, I see a plus sign, so I want to subtract on both sides, but we need to add. You can think of it as like a positive 8 is the opposite of a -8. the end of the day, remember what we're trying to do. We want these to cancel, and the way they cancel is by equaling 0. To get a 0, we are going to need a -8 and a +8. If I had another -8 here, that wouldn't give me 0. So -8 plus 8 gives me 0. It cancels out. So all I would be left with is my 6m. What about this -14 plus 6? Plus 6 plus 8? What did you say? I kind of gave away the answer. It would be -6. -6 because they are different signs, so you want to subtract, and then you're keeping the sign of the larger number. My last step, if I'm trying to get m all by itself, I want to come in and divide by the 6. When I do that, it's going to give me m equals -1. 6 divided by 6 is 1, and then different signs means negative. There is one last example, and that last example is this fun-looking equation right here. Usually what I'll do when I have students in the classroom is I have them try this first. You know everything you need to know to solve this equation. It's just combining all of this knowledge you have into one problem. So I'm going to have you go ahead, pause the video, try this first, and then come back to see how you did. Even if it's just trying to start the problem but you get stuck, I give it a go before you see what it looks like solving it. All right, how'd you do? Did you get far? Did you get to an answer? The first thing you would want to do here is notice all the stuff happening on this left side of the equation. I see distributing, I see combining like terms. It actually goes back to that question we did on the do now, that review question at the beginning of the lesson. The first thing we want to do is distribute. I want to start by multiplying my 2, and it would leave me with this. 2 times 4p is 8p, and 2 times that minus 3 is -6. Once we do that, now I'm looking here, there's still 4 terms on the left side of my equation. I can continue by simplifying and combining like terms. So looking over here at what I can simplify, I could always say that 8p minus 2p gives me 6p. I just copied everything else down. There's still more we can simplify. We could still simplify even more by combining that -6 and -8. When you do that, you want to be careful. They are both negative, and if they're both negative, that means you want to add and keep that negative sign. So we get 6p minus 14 equals 4. After that, now it's a two-step equation. So I bet you if you didn't get to this point, you could probably take over now if you wanted. I could come in next and say, well, that -14, let me add that on both sides. That would give me the 6p equals 18. And then my last step, let me divide by the 8, or sorry, by the 6. And when I do that, it leaves me with p equals 3. Ta-da! Look at all of that crazy work. But you're doing it. We started just last week with like those tiny little one-step equations, but now we've gotten to much more than one-step equations. But it's using all these things you know, right? We learned how to do one-step equations. That's right here. We learned two-step equations. And then the rest of this is just using what you learned at the beginning of this unit with distributing and combining like terms. Now, I do want to mention with this equation before we move on that even though these are all the different steps you need to do in order to solve this equation, there are still multiple ways you can solve this equation. This is one way, and I would argue that this is probably the most common way you would see, but there are lots of other different options. For example, at this step right here, I'm going to try writing it down. Instead of combining that -6 minus 8 next, some students instead I've seen will go in and say, okay, I want to get rid of my constant. And I'm like, oh, okay, what's your constant? And they'll say, we have 2 constants. We've got a -6 and a -8, so I need to get rid of both. Let's say if I want to get rid of the -8, I would want to add 8. If you do that, are you doing anything mathematically wrong? The answer is no. There's nothing wrong with adding 8 on both sides. You might not like their way, or maybe you do like their way, but there's nothing mathematically incorrect about doing that. It might look different than what we're doing over here, because if you add 8, those would give you 0. They would cancel out. So we're left with 6p minus 6 equals 12. If you're left with that, well, then next you would want to, I guess, get rid of the other constant, right? Get rid of that minus 6, which we could do by coming in and adding 6 on both sides. And notice when we do that, what are we left with? Well, again, these are going to cancel, and we're left with 6p equals 12 plus 6, which is 18. And then notice that line right there is the same line that we had here. This is just one example, but I show it to say that, especially, you're at home, so I can't even see what you're doing. But as you're solving these equations, if your steps don't necessarily look exactly like what I'm showing or what another student's showing, it doesn't necessarily mean you're doing anything wrong. Or vice versa, if you are looking at someone else's work and they're doing it a different way than you, what I want you to really ask yourself is what they're doing, is it mathematically wrong? Like, are they saying 4 plus 8 equals 32? Because that's not right? 4 plus 8 does not equal 32. That would be multiplication. So asking yourself, is it mathematically wrong, or is it just a different strategy, a different method than what I am doing? This, I would argue, is a different method, right? You might not like the order they did this in. You might prefer this, or you might prefer this and not like what I just did. But both of them are mathematically valid. They're both correct ways to solve the equation. I am going to move us right along. To summarize what we did here, in this equation, the first thing we had to do is we had to start off by multiplying, or the math word we learned for that is distribute. We need to distribute first. After that, the next thing we did in these steps here was combine our like terms. Again, it kind of, when we had seen this, not in equations, but just with expressions, we talked about how this relates back to order of operations, or PEMDAS. This is just basically saying you need to multiply before you add and subtract. And we're carrying over those rules into solving equations with variables. I've talked enough. It is now your turn to try. This one here is the one that you're going to solve. All right. So to start, you would want to start by distributing. Make sure you're very careful when you distribute. It's not just a 4 we're multiplying by, but a -4. When we do that, -4 times f gives us -4f. -4 times 1 gives us -4, and we are left with this right here. Next step is to combine. That 6f minus 4f gives me 2f. And then again, you want to be careful here that -4 plus 8, -4 plus 8, that's the same thing as 8 minus 4, which is a +4. So I've got 2f plus 4 equals 12. When we get rid of our constant, we are, there it is, subtracting 4 on both sides. When we do that, the 4 minus 4 is going to cancel out, and the 12 minus 4 is going to give us 8. Last step, divide by 2. Divide by 2. And when we do that, we are left with f equals 4. Of course, you would want to check that if you put 4 right here into the equation and right here into the equation. You would want to make sure that this left side here equals 12, which it does. There is one last part to this, and it's kind of related to, there we go, to what we were saying earlier with looking at other people's work and asking ourselves, are they using a different strategy than me, or are they mathematically doing something wrong? And it has to do with these error analysis problems. you've been a student of mine for a while, you know I love these. And the reason I love these so much is you really have to think critically. You really have to understand how to do these problems in order to look at someone else's work and identify a mistake, if there is a mistake. I mean, just think about how much Denise and I have to understand this to look at your all's work and say, like, here is where they went wrong. So it's there are great questions to see where you all are at in that ability. So the question here says John was asked to solve the equation. His work is below. Did he solve the equation correctly? Why or why not? So we can see that the equation is 2x plus 2 minus 4 equals 8, and then his work is below. Now, for some people, they can just look down here at the work and say, okay, there's the mistake. That's not right. Other people, a strategy that they use is doing the problem themselves. Don't look at the work at all, just do the problem themselves. And then they can compare their work to, in this case, John's work. It's up to you how you want to do it. I'm going to have you go ahead, pause the video now, see if you can find that mistake. All right. You are coming at this from the strategy of doing the math yourself. The first thing I would do right here on that left-hand side is I would see, well, there's things I can combine. I notice I can combine the two numbers, so that positive 2 and that negative 4. And when I do that, a positive 2 and a negative 4, they're different signs. I'm subtracting and keeping the sign of the larger number. It would leave me with 2x minus 2 equals 8. Right there from the beginning, I've got different work than what they've got. So I want to come and check to see, what did they do? Did they do something mathematically wrong, or are they just coming at the problem from a different direction than I am? When I go to compare, I see, well, they've got the 8 the same, they've got the equal sign the same, they've got the minus 4 the same. What's changed is instead of a 2x plus 2, they've got 4x. So using that observation that they've changed 2x plus 2 to 4x, I've got an idea of what they did. They changed 2x plus 2 to 4x, they probably added 2x plus 2. They said the 2 plus 2 gives me 4, and then write down your x. 2x plus 2 equals 4x. Is that correct? Can we say 2x plus 2 equals 4x? The answer is no. You cannot add a variable with a number. That is the reason over here where we combined the 2 minus 4. Those things are both numbers. You can combine them. You can't combine a variable or an x with a number. So that helps me answer this question. Did he solve the equation correctly? The answer is no, he did not. Why or why not? If I'm asking you why he didn't solve it correctly, you want to specifically mention what mistake he made. You don't want to say, no, he didn't solve it correctly because the answer is 5. I don't know what the answer is, but that's not addressing the mistake he made. We want to specifically mention why John got this problem wrong. And he got this problem wrong because of that initial mistake here. So we could say, no, he did not. In the first step, when he went to combine like terms, he combined 2x plus 2 equals 4x. That is that initial mistake that gave him the wrong answer. So I've identified his mistake. I'm also going to help say why it's a mistake. So we've got you can't combine a variable with a number, so this gave him the wrong answer. I want to point out a couple other things with this. Notice I didn't keep going. So sometimes students will do exactly that. They'll find that initial mistake, and then they'll say, so he was adding 4 on both sides when he needed to add 2 on both sides, and he was dividing by 4 when he needed to divide by 2. You don't need to keep going. I think a lot of us understand math well enough to know if you make a mistake at the beginning, the majority of the time it's going to affect all the later math you do. So when I'm asking you to identify a mistake, we don't need to keep identifying all the repercussions of that mistake and keep going. Just identify the initial mistake. Of course, the way you've written this can and will look different than what I've got here. When you're looking at your explanation, check to see, did you identify exactly what he did wrong and did you correct him? So you could have also said he combined 2x plus 2 and instead he should have combined the 2 minus 4. That's another option. But we really want to get at specifically where the mistake is and not just say, did he solve the equation correctly? No, he didn't. He made a mistake. You want to be specific what that mistake is. That is everything I've got in this video. Hopefully you found this helpful. Thanks so much for watching and goodbye.